All right, today we are going on a journey way, way back in time. We're talking over 500 million years ago, right to the dawn of the very first animals with backbones. We're going to explore a world that was ruled by these bizarre armored fish and uncover the incredible evolutionary coup that literally changed life on Earth forever.
I mean, just think about that for a second. It's a pretty strange thought, isn't it? We totally take jaws for granted, for eating, for talking, for everything. But for the first 100 million years of vertebrate history, they just didn't exist. This was not a world of sharks and piranhas. It was something much, much weirder.
And what's really wild is how completely that jawless world has vanished. I mean, look at this number. Today, a whopping 99% of all living vertebrates have jaws. That means the creatures we're about to meet, the true pioneers of the backbone, they represent a totally different and almost completely extinct branch on the tree of life.
Okay, so to understand this story, we need to meet our two main players. First up, you've got the Agnatha, which literally just means without jaws. These are our ancient heroes. And then you have the Gnathostomata, or jawmouth. These are the newcomers, the revolutionaries, and spoiler alert, our direct ancestors. Their names really say it all. This whole epic saga really boils down to that one critical feature.
So let's break down the differences because it's about way more than just the mouth. The Agnathans, they had no jaws, obviously, but also, and this is huge, no paired fins. That means they couldn't really steer precisely in the water. They also kept their primitive notochord, which is like a flexible rod, their whole lives. In jawed vertebrates like us, that gets replaced by a real, bony vertebral column. Heck, even their nostrils were different. Just a single one for the jawless guys versus the paired nostrils that we have.
Now let's fire up the time machine and head back to the early Paleozoic. The seas were just teeming with life, but it was a kind of life that would look totally alien to us today. This was the age of the Agnathans. This was the reign of the armored.
You know, the Agnathans were absolute pioneers. They first show up in the fossil record way back in the Cambrian, over 500 million years ago. Then, through the Ordovician and Silurian periods, they really hit their stride, diversifying into all these wild and crazy forms. For tens of millions of years, they were the undisputed kings of the vertebrate world. But then, during the Devonian, everything changed.
So what did these animals actually look like? Well, check this out. Here we see one of the most successful groups, the ostracoderms. Honestly, they look less like modern fish and more like, I don't know, armored torpedoes. They were the very first vertebrates to evolve bone, but not for an internal skeleton. It was a heavy external shield.
So their whole deal was this crazy outer armor, a total lack of paired fins for agile movement, and these simple, sucking mouth parts. Internally, their skeleton was all cartilage, kind of like a modern shark. You can basically think of them as armored, bottom-dwelling mud grubbers, just cruising around a world that didn't have any true predators yet.
But that peaceful, armored world was about to be turned completely upside down. A new evolutionary innovation was about to appear. One so incredibly powerful, it would literally rewrite the rules of life on this planet. It was a revolution.
Jaws. It seems so simple, doesn't it? But this one adaptation was, without a doubt, the single most important development in early vertebrate history. It was a true biological killer app, and the poor Agnathans, well, they had no answer for it.
So where did jaws even come from? They didn't just pop into existence out of nowhere. The leading idea is that they actually evolved from the very first pair of gill arches. Those are the bony or cartilaginous structures that support the gills. The whole process probably started when these front arches got a hinge, which helped pump water over the gills more efficiently. Then, over evolutionary time, this new hinge structure was repurposed for a brand new job: grabbing and biting. It's a classic case of evolution just tinkering with parts that are already there to create something totally new and revolutionary.
And the advantages were immediate and just immense. I mean, all of a sudden, you could eat bigger, tougher food. You could become an active hunter instead of just sucking up muck from the seafloor. You could defend yourself. Jaws even made breathing better. It was a complete game changer that opened up all these new ways of living.
So with the rise of these new jawed fish, the gnathostomes, the long reign of the Agnathans began to crumble. But it wasn't some sudden dramatic apocalypse. It was this slow, creeping replacement that has puzzled paleontologists for decades. So, what really went down?
The prime suspect has always been competition. The idea is pretty simple. The new, more adaptable jawed fish were just better at getting food and finding space, and they slowly squeezed the jawless ones out of the picture.
Yeah, that's the million-dollar question, right? It's not like you can put an ostracoderm and an early shark in an aquarium and see who wins. So how do paleontologists play detective and solve a 400-million-year-old mystery?
They do it with some really clever workarounds. Scientists use morphology, basically an animal's body shape, to figure out its lifestyle. The core idea is that form follows function. So animals with similar body shapes probably lived in similar ways and ate similar things. If you find a jawless fish and a jawed fish that have really similar body plans, that's a huge clue that they were probably fighting over the same resources.
So, what's the verdict? Well, like most things in science, it's complicated. Recent studies that compared the body shapes of hundreds of these ancient fish found that, yeah, for some groups, the competition idea really works. But for others, their body plans were so different from the new-jawed fish that direct competition just doesn't seem likely. The big takeaway here is that there probably wasn't just one single reason the agnathans declined. It was likely a mix of things: competition, changes in the environment, and maybe even just getting eaten.
Now, what's truly incredible is that two groups of agnathans actually survived this whole takeover and are still around today, the hagfish and the lampreys. And for more than a century, these two bizarre survivors created a massive scientific debate, a kind of prehistoric family feud about who was related to whom.
So on one side, you have hagfish. They're these deep-sea scavengers famous for producing just an insane amount of defensive slime. They've got a skull, but no actual vertebrae. On the other side are the lampreys. Many of them are parasitic, latching onto other fish. And they have these little rudimentary vertebrae made of cartilage. For decades, scientists just could not agree on how they were related. And this was the huge question. Do hagfish and lampreys form their own little exclusive jawless club? Or, as some of the anatomical evidence suggested, were lampreys actually more closely related to us, the jawed vertebrates, leaving hagfish as this even more ancient, separate group? The answer would totally change how we understand the very base of the vertebrate family tree. The whole debate was finally settled by genetics. Now, I know these family trees look a little complicated, but the answer they gave us is incredibly clear. Scientists compared dozens of genes, and the results were just overwhelming. See those numbers on the branches? 100, 100, 99? In science, that is about as close to 100% certainty as you can possibly get. The DNA evidence was definitive. Hagfish and lampreys are in fact each other's closest living relatives. The family feud was finally over. So, we've traveled from the ancient Cambrian seas all the way to modern DNA labs. But why does this story, this evolutionary takeover from 400 million years ago, still matter to us right now, today? Because everything that makes us a vertebrate, everything that makes a lion, a lizard, a bird, or you, is built on the foundation that was laid by those very first successful gnathostomes. Our jaws, our arms and legs, our complex immune systems, our very bones, all of these are traits from that revolutionary new body plan that won out over the jawless pioneers. We are the direct descendants of the winners of that ancient evolutionary war. And that brings us to our final thought. What if that first gill arch had never developed a hinge? What if that jawed revolution had just never happened? Would the ocean still be ruled by armored, mud-sucking fish? Would life on land even be possible? It's a world that's almost impossible to imagine, and it all hinged on a single, brilliant accident of evolution. Thanks for tuning in.